So the second part is 5.5 is 5.5b. We're going to talk about composite functions and how we go about dealing with different types of composite functions. So what is a composite function? A composite function is the result of applying the rule of one function f to another rule or to another function g to create a new rule. Now that new rule is denoted as f of g of x, f of g. So kind of a fog type of situation. And notice that circle is an open circle. It's not closed. Closed means multiply. Open means it's a composite function. So just like we had with adding and subtracting and all of those different things, we had those different rule things. There's two ways to write a composite function. You can either write it f of g of x, and that's what that means, f of g of x. And the next one means the same thing as well, f of g of x. So we've got our two rules in here. So the operation that the composite, it's called the composition of a function, or a composition of functions. Now, the domain in the range, the domain of f of g of x is the set of all real numbers in the domain such that g of x is the domain of f of x, and the domain of the composite function is the intersection. We're not going to worry about that piece of it too much with the domain and the range, just kind of keeping in mind of those two different things that we have within here, that we have that f of g of x means that we're going to apply the rules, and we're going to apply those rules from the inside out. So let's look at a couple of examples of these. So we've got, we're going to let f of x equal x squared and g of x equal x plus 1. We're going to investigate what happens when you apply the rule g and then the rule f to the number or to the variable. Now this says we're going to find f of g of 3. So what that essentially means is that it means we need to evaluate our g function at 3 first. So we're going to take our g function, which is x plus 1, and we're going to substitute into our x value 3. So if we look at the x plus 1 function, our g function is x plus 1. So in a sense of the imagination, we should probably get rid of the highlighter. Change colors here. If we look at what g of 3 is, well, our g of x function is 3 plus 1, so 3 plus 1 is 4. So then essentially what this means is then we're going to apply the rule to the f rule if our x value is 4, because g of 3 was equal to 4 by applying it in there. Now we're going to look at the f function, and anywhere we see an x, we're going to replace it with a 4. So the f function is x squared, so we have to essentially find f of 4, which is x squared, so our x value is 4. So 4 squared is equal to 16. And that's our evaluation of this composite function. We're going to get 16 for it. So we're finding f of g of 3. So you find g of 3 first, and then you find f of whatever the result was for finding g of 3. The next one then that we're looking at, it says let f of x equal x squared and let g of x equal x plus 1. So same thing, but now we're going to see what happens if we just say let's find f of g of x. So we don't know the x value, but that's okay. We know what g of x is equal to. So we're just going to substitute g of x in there. So essentially what we're going to find with this then is we're going to find f, but I'm going to substitute the g of x for what I know g of x is equal to. And g of x is equal to x plus 1. So now I have to find f evaluated at x plus 1. So again, talking about functions, what that means then is that anywhere I see an x now in the f function, I need to replace it with an x plus 1. So f of x is equal to x squared. So f of x plus 1 is going to be x plus 1 squared. And you could FOIL that out and get x squared plus 2x plus 1. Same thing, get the same solution for that problem. So now let's take a look at this next example. So we've got let f of x equal 2x minus 1, let g of x equal 3x. We want to identify the rule for each of these. So we're going to find f of g of 2. So we look at our g function. Anywhere we see an x in our g function, we are going to replace with a 2. So g function is 3x. So let's change this color again. So g of 2 is 3 times 2, which is 6. So that means I need to find f of 6. So anywhere in the f function that I see an x, I'm going to replace it with a 6. And that's 12 minus 1, which is 11. Let's go ahead and do the next one. Next one says f of g of x. So now we don't know what to substitute in there, but we know what g of x is equal to. G of x is equal to 3x. So this means we're going to find f of 3x. So in our f function, anywhere we see an x now, we're going to replace it with a 3x. Now the common error here is to forget to put that minus 1. Make sure you put that. 3x times 2 is 6x minus 1. That then is your general rule for this one. Okay? Okay, so now let's take a look at writing the different composition functions. Because this is the same thing, it's just a different way to write it, f of g of x. So we've got to find, essentially, I like to do, when I see fog, I'd like to rewrite this like this. It just, in my mind, it helps me do these a little bit better. So now I've got nothing to substitute in there, so I know what my g of x value is 2x minus 5, so that means I need to find f of 2x minus 5. So anywhere in the f function that I see an x value, I have to replace it with 2x minus 5. So that's going to be equal to the square root my x, but my x now is 2x minus 5. And then I've got the plus 7 to add in there, so that's the square root of 2x plus 2. And that was a nice circle. So you get 2x plus 2 for that one. All right, let's go to the next one. So now again, we're going to find that f of g of x, and there are two functions. Being me, I like to write it first. F of g of x. My g of x function is 4 minus x, bell time. So in my f function, anywhere I see an x in my f function, I'm going to replace it with 4 minus x. So that's going to equal x squared, so this has to go in parentheses. So 4 minus x squared plus x, so that's 4 minus x. Again, you can put it in parentheses, you don't have to, plus 2. I'm going to simplify this. So 4 minus x, so we should be able to do these quickly now. So that's 16, 4 squared is 16, minus 4x, so minus 8x, plus x squared, plus 4 minus x plus 2. Now write it in standard form. So that's x squared minus 9x. 16 plus 4 plus 2 is 22. If I did that all right, then that one should be good to go. Okay, so now we're looking at just ones that I want you to define yourself. So this one says identify the rules for f of g of x and g of f of x. So why don't you go ahead and let's just do one of these. Let's just do A. So go ahead and do A. You have to do it twice. You have to find f of g of x, and you have to find g of f of x as well. And when you find those, then you can kind of peek up and see how you did. Okay, so those are your two solutions. You get x plus 1 cubed, and that's good enough. Don't break that out. That's good enough. And then you get x plus 1 cubed. And then the other one, you get x cubed plus 1 for your solutions for that one. The last page then that we're going to look at is we're just going to look at, we've got the composite function things down now. Now we're just going to kind of look at some different ones that what your assignment will look like. The assignments the last couple days have been looking a little bit different, but it means the same thing. I just wanted you to kind of get a few examples of what exactly they're going to look like today. And we're just going to do a couple of these. We're certainly not going to do all 4 of these. We're just going to do a couple of them just to kind of get you into the groove of how they go. So the first one up here, we'll call this one number 1. We've got g of x is equal to 3x plus 4, and h of x is equal to x plus 4. You're asked to find g of h of 9. Okay, so we're going to evaluate them at 9. So so the first thing we need to do is we need to evaluate the h function at 9. So h of 9 is going to be 9 plus 4, which is 13. So because we're evaluating it now, we have to find now g of 13 because our h of 9 was 13. So now anywhere in the g function where we see an x, we're going to replace it with a 13. 3 times 13 is 39. 39 plus 4 is 43 is your solution for that one. Okay? We're going to go ahead and go straight down and do this bottom one, and this will be the last one that we do. In this case, we got to form a rule, it looks like. We're going to find g of h of x. Remember, when I do these, I like to rewrite it. So g of h of x. No numbers to evaluate, so we have to use substitution. We know our h of x function is 2x plus 1. So anywhere in the g function that I see an x, I'm going to replace it with 2x plus 1. So that's going to equal, so I've got my x, so that's 2x plus 1 cubed plus 2, and we'll call that good enough. Okay? So there's composite functions, and finishing up composite functions and really finishing up section 5.5b. So that takes care of section 5. We will, you're going to be doing this after you take your quiz. So we'll move on to section 5.6 probably on Thursday of this week. So everybody have a good day. Stay safe out there, and we will see you next time.